We now have the concept of coefficient of determination, which is called R squared. And this is going to tell us what percentage or proportion of the variability in our data is explained by our model. So it's always between 0 and 1 with values closer to 1, meaning that the model explains the data well, values closer to 0, meaning a poorer explanation. Whereas correlation, the little r that we've talked about, only assesses how well a line fits the data or how strong our linear relationship is. R squared is more general in that it allows us to look at how well a curve would fit or things like that. But when we're talking about a linear fit, it does also assess how well the line fits. So we want to match each of these values of R squared to each of these 4 pictures. So the first one, R squared equal 0.98, is going to be the one that has the best fit. And the one we see that has the best fit is this one with a very strong linear fit. The R squared of 0.79 is going to be the second best fitting one, and that's going to be this one right here. So in this picture, we have fit a curve to this data set, and this curve fits rather well. Note that where in this first picture that we talked about that we would also have a high value of R, our correlation, in this one we would actually have a low value of R because R talks about how linearly related the variables are. So R squared can be high with a low value of R when we have something other than a linear relationship. In those cases, we can have this disconnect between R and capital R squared. The other two we have, this one is going to be the next one, 0.32. It fits okay. It's not the best fit. And finally, this one is going to be our 0.0016. If we'd fit a curve here, we would have a high value of R squared because it would be explained well, but this line that we fits very poorly, and so we have a very low value of R squared.